A brilliant diamond is actually a lump of coal or carbon found in the depths of the earth. Hello and welcome to another science lesson. Carbon, an important element. And in this unit, we will only be learning about the crystalline allotropes of carbon. What is this allotropic nature of carbon? Some elements like carbon occur in nature in more than one form. The chemical properties of these different forms are the same, but their physical properties like density and how they look, they are different. So when an element occurs in more than one form, having the same chemical properties but having different physical properties, that those forms are called allotropes, and this property is called allotropy. Now, like carbon, other elements like sulfur and phosphorus also show this property of allotropy. The allotropes of carbon. First, we have the crystalline allotropes, examples of which are the diamond, graphite, and fullerene. And we have another form of allotropy, that is non-crystalline or amorphous form, and examples are coal, charcoal, and coke. The crystalline form, or what is a crystal? A crystalline form has a regular and definite arrangement of atoms. As you can see in this picture, the atoms are arranged at specific places, and there is a definite shape. It has high melting and boiling point, and a crystalline form has a definite geometrical shape. It has sharp edges and plane surfaces. Structure of a diamond, which is the first crystalline allotrope of carbon. In a diamond, every carbon atom is bonded or joined to four neighboring atoms by covalent bonds. These black lines which you see joining the carbon atoms, they are symbolizing covalent bonds. And covalent bonds means chemical bonds formed when electrons of the atoms are shared. Now, due to this three-dimensional structure which is formed, the diamond becomes very hard. Properties of a diamond. Brilliant and pure diamond is the hardest natural substance. Second property, the density of diamond is 3.5 gram per centimeter cube. Density means how thick it is. It is a measure of how much stuff is in a given amount of space. So diamond density is very high, 3.5 gram per centimeter cube. The melting point of diamond is 3500 degrees Celsius. Very, very high melting point. As we see, crystalline substances have high melting points. When a diamond is heated at 800 degrees Celsius in the presence of oxygen, no other product besides carbon dioxide is given out. Another property, diamond does not dissolve in any solvent. Means you put it in water, you put it in kerosene, you put it in milk, you put it in acid, it will not dissolve. Acids and bases have no effect on a diamond. Diamond is a bad conductor of electricity because it is so densely packed and it does not have any free electrons, and so it does not conduct any electricity. Uses of a diamond. Diamonds are used in glass cutting and rock drilling machines. You know, glass and rock are hard substances, but diamonds are harder still, and so they are used to cut glass and to drill the hard rocks. Beautiful ornaments are made from diamonds. Diamond knives are used in eye surgery. Diamond dust is used for polishing other diamonds. Diamond is used to make windows in artificial satellites, giving protection from radiation in space. So they make the windows of the satellites that go into space. Some diamond coating is there to protect it from radiation. And what is radiation? The energy that comes from a source and travels through space at the speed of light. So to protect from that, windows using glass filter is used. The second crystalline allotrope of carbon is graphite. What is graphite structure? Every carbon atom in graphite is bonded to three other carbon atoms in such a way that a hexagonal or a six-sided figured layered structure is formed. You can see here all these dots are carbon, six atoms, okay, and forming a hexagonal structure, three of them joining with three others, and they form one layer on top of the other. A graphite crystal is made up of many sheets or layers of carbon atoms, so one layer on top of the other. These layers slip over each other applying pressure, and one layer of graphite is called graphene. Can you see the structure here? One layer on top of the other, they go one on top of the other and they are called graphene. Properties of graphite. Graphite found in nature is black, soft, brittle and slippery. Though it is a crystalline allotrope of carbon, can you see the difference between diamond and graphite? Big, vast difference. Inside each layer of graphite, free electrons move continuously within the entire layer, so graphite is a good conductor of electricity. Exactly opposite to diamonds where there are no free electrons, and diamond is a bad conductor of electricity. The density of graphite is 1.9 to 2.3 gram per centimeter cube, in comparison to the density of diamond, which is 3.6 almost. Graphite does not dissolve in most solvents. A solvent is a liquid in which something dissolves, or a solute is dissolved to form a solution. And this is the difference between the structures of diamond and graphite. The uses of graphite. Graphite is used for making lubricants. Now, a lubricant is a substance like grease and oil which reduces friction and heat when put between solid surfaces. For example, if the fan is making a little noise or if the door doesn't open properly, we just add a little grease or oil there and it starts functioning better. So that is called a lubricant. So graphite is used to make such lubricants. Graphite is used for making carbon electrodes in cells. Okay, graphite is used in pencils for writing. So the very pencil that you're writing has the crystalline allotrope of carbon called graphite. Graphite is used in paints and polish. Graphite is used in arc lamps which give very bright light. Now, arc lamps, intense bright lights like searchlights, floodlights, projector lights, etc. The third crystalline allotrope of carbon is fullerene. Fullerene is rarely found in nature. It is found in soot and in interstellar space. Interstellar space is the space between the stars in a galaxy. And soot is when we burn wood or something, we get that black colored substance which collects in a chimney, that is called soot. The first example of fullerene is Buckminster fullerene. C60. It is named Fullerene after the architect Richard Buckminster Fuller because the structure of C60 resembles the structure of the geodesic dome he designed. Now he was an architect. He built a dome, which is like the upper part of the Taj Mahal. That kind of a thing he built, and that looked like Fullerene, and therefore it was called Buckminster Fullerene after him. Harold Kroto, Robert Curl, and Richard Smalley were given the Nobel Prize in Chemistry in 1996 for the discovery of fullerene, that is the allotrope of carbon called C60. C60, 70, 76, 82, and C86 are other examples of fullerene. Their molecules occur in small numbers in soot. Properties of fullerene. Molecules of fullerene are found in the form of buckyballs and bucky tubes. You see how they are formed, these are the structures, two different types of structures. There are 30 to 900 carbon atoms in one molecule of fullerene. Fullerenes are soluble in organic solvents such as carbon disulfide and chlorobenzene. Uses of fullerene. It is used as an insulator, meaning when you don't want to get a shock, and something that does not conduct electricity is called an insulator. They are also used as catalyst in water purification. Now, when water is being purified, the process takes a very long time. So this fullerene is added as a catalyst. It helps the reaction to take place faster. At a certain temperature, fullerene exhibits or it shows superconductivity, means it conducts electric current with no resistance at all. Give reasons. Graphite is not a good conductor of electricity. You know this answer because inside each layer, free electrons move continuously and therefore it is a good conductor of electricity. Graphite is not used to make ornaments. Graphite is soft, black and slippery, and we need hard metals to make ornaments. Since graphite is not hard, it cannot be used to make ornaments. Diamonds are used in rock drilling machines. This answer also you should already know. Diamond is a crystalline allotrope of carbon. Each carbon atom in diamond is linked to 4 other carbon atoms by covalent bonds, which makes it very, very hard. Therefore, it is used in rock drilling machine. Distinguish between diamond and graphite. Read through these 4 points. These are the main points of distinction between diamond and graphite. One is hard, one is soft and slippery. Diamond is a bad conductor while graphite is a good conductor. Diamond is used as an ornament and to cut glass because it is hard, whereas graphite, because of its slippery and soft nature, it's used in paints, polishes and as a lubricant. In a diamond crystal, each carbon atom is linked to 4 other carbon atoms at specific distances. Whereas in graphite, every carbon atom is bonded to 3 other carbon atoms in such a way that a hexagonal layered structure is formed.